This video will show the relevant content of incineration and municipal solid waste treatment chosen by our group. Our group members include Jin Chen, Jun Yuran, and Jia Luyu. We will introduce from 4 aspects. The first part is the introduction. We will discuss the application of incineration technology, its potential impact on recovery rate, range of fuel feedstock and treatment, and boiler technology. The second part is enhancing sustainability in projects, where we will discuss efficiency improvement, environmental impact assessment, and public acceptance. The third part is waste management. We will discuss challenges and solutions, waste disposal, waste classification, current situation, and development trends. The first part is conclusion. Incineration is a key component of the waste-to-energy system, which involves burning waste at high temperatures, converting it into ash, smoke, and heat, and then providing electricity or heat for industrial processes. Urban solid waste refers to waste generated from various sources, including various materials discarded by urban residents and commercial institutions. After collecting urban solid waste through various channels, recyclable and harmful waste are separated, and the remaining waste is transported to the incineration treatment site. Before incineration, further treatment such as crushing is carried out to optimize combustion and improve energy recovery efficiency. The sufficient combustion is carried out in the incinerator, and the generated heat hits the water in the boiler to produce high-pressure steam. The steam is then directed to the turbine to generate electricity using its rotational energy. Some facilities can capture and recover additional heat from the flue gas, which can be used for regional heating or other industrial applications. The pollutants generated during the incineration process will also be captured and treated. The remaining non-combustible materials after incineration will also be further treated or buried in landfills. The impact of incineration technology on waste recovery rate is complex and depends on specific circumstances. If waste incineration is considered the main method of waste treatment, then recycling may not be given as much importance. If a large portion of the waste is directly incinerated, the materials available for recycling programs may be reduced. The government's policies and investments in waste management infrastructure will also affect the balance between incineration and recycling. Incineration technology has a wide range of applications and can be applied to various types of waste. Incineration is a common method for managing urban household waste, as it reduces the volume of waste, minimizes the demand for landfill space, and can generate energy. The combustion of biomass can generate heat and electricity, and the resulting ash may have agricultural applications. It can be used for safe disposal of contaminated waste from hospitals or labs. It can be used to incinerate harmless industrial waste such as paper and wood. It can be used to handle certain types of hazardous waste, such as waste oil and solvents. The sludge from sewage treatment plants can be incinerated to reduce its volume and generate energy. Although traditional incineration may not be suitable for e-waste, as it releases potential harmful substances, some advanced technologies, such as waste incineration with integrated gas cleaning system, can be used to manage certain components of e-waste. The selection of boiler technology during the incineration process is a complex decision that requires consideration of specific waste characteristics, regulatory requirements, energy recovery goals, and environmental factors. There are many different types of boilers, each with its own advantages and applications, and we should choose the most suitable type according to its requirements. In the context of waste incineration, boiler technology plays a crucial role in converting the heat generated by waste combustion into steam. The higher the efficiency of steam generation, the higher energy recovery rate. Then steam can be used for power generation or to provide heat for industrial purposes.
Then we are going to talk about the changes and solution for emission control. Here are 3 points about the changes. Firstly, the emission of harmful substances such as dioxins during the incineration process is difficult to control and pose a threat to the environment and human health. Secondly, the control of parameters such as temperature, oxygen concentration, and incineration time during the incineration process is difficult and requires high-level technical and equipment support. Last one, both exhaust gas treatment and waste residue treatment during the incineration process requires a lot of energy and capital, resulting in high costs. The current solution to these changes mainly include the following: adopting advanced combustion technologies such as high-temperature combustion and low-nitrogen combustion to control parameters such as temperature and oxygen concentration during the incineration process, reducing the production and emission of harmful substances. Then adopting advanced exhaust gas treatment technologies such as activated carbon adsorption and catalytic oxidation to treat harmful substances generated during the incineration process, reducing their impact on the environment. Then adopting advanced waste residue treatment technologies such as solidification and stabilization to treat waste residue generated during the incineration process, reducing their impact on the environment. Next, about the waste disposal. The main method of waste disposal of ash includes solidification and stabilization techniques. Solidification involves mixing the waste residue with a solidifying agent to form a hard solid under the action of the solidifying agent, reducing the volume and stabilizing and harmless the waste. Stabilization involves adding chemical agents or physical methods to convert the harmful substance in the waste residue into stable compounds, reducing the release of harmful substances and stabilizing them. The treatment of byproducts after waste disposal mainly include resource utilization. For example, ash can be used to produce building material such as cement and concrete and can also be used for road construction. The importance of waste classification lies in its ability to help us better manage and dispose of waste, reduce environmental pollution, and improve resource utilization. Two main waste categories can be established based on the distinct legislation and policy instrument usually in place: non-hazardous or solid waste, and hazardous waste. Non-hazardous is all waste which has not been classified as hazardous: paper, plastics, glass, metal and beverage cans, organic waste, etc. While not hazardous, solid waste can have severe environmental and health impact if left uncollected and untreated. Hazardous waste is waste that has been identified as potentially causing harm to the environment and human health, and therefore need special, separate treatment and handling. E-waste is generally classified as hazardous because it contains toxic components. Medical waste can be infectious, toxic, or radioactive, or contain bacteria and harmful microorganisms. Radioactive waste contain radioactive materials, so they are all hazardous waste. We know the principles of garbage disposal are harmlessness reduction and resource utilization. The main method of harmless treatment of domestic waste is in various countries around the world include landfill, composting, and incineration. Among them, domestic waste incineration power generation is a new technology developed in the past 30 years. Compared with landfilling, it can save a lot of land resource, reduce possible secondary pollution, and convert waste into energy resource. Utilization has therefore increasingly become the main method of waste disposal in some developed countries. Among the harmless treatment methods of domestic waste, waste incineration power generation has the advantage of saving space, significant reduction, more through harmless treatment, and can be converted into energy. It has attracted more and more countries' attention. The proportion of waste incineration power generation is increasing year by year, and it will become an important direction of new energy development in the future.
The efficiency of energy recovery and incineration technologies for power generation is also an issue that deserves our attention. There are a huge number of factors that can affect it, and I have listed some of them. First of all, the moisture content of waste. Waste with high moisture contents consumes more energy when burned. It will reduce combustion efficiency. And choice of fuel and its degree of combustion. The more fully the fuel is burned, the more efficiency it will produce. The choice of fuel is also critical, and if the fuel chosen contains a high level of contaminants, the operation of the generator will also be impacted. Exhaust gas treatment systems. Effective exhaust gas treatment systems can reduce emission levels and improve energy recovery efficiency. The above 3 points are mainly in the incineration process, and the recycling of waste residues after incineration can further improve the energy recovery rate, which is also a point that should not be ignored. This is a power station in Lahti, Finland. The station used only recycled household and industrial waste as fuel, and tests each truckload of fuel to insulate this fuel so that it can generate electricity more efficiently. As a result, it generates 30% higher electricity output and heat output than comparable power plants. To improve efficiency and be more environmental friendly, factories can improve their technology in 3 ways. To start with, enhance waste pre-treatment technologies. Industry can remove the impurities in the waste in advance that may cause harm to the equipment. Then, during the process of incineration, some intelligent control system can be used for more precise controls to improve efficiency. After incineration, proper disposal of waste gases and residues can be used to reduce the influence on the environment, such as SCR and SNCR, which are both able to reduce the emission of nitrogen oxide. It cannot be ignored that incineration also has a certain impact on the environment. We can explore its impact for 3 aspects: social, environmental, and economy. First, we start with the environmental way. There will be air pollutant emissions. and the generation of waste residues in the incineration process. This will affect air quality, and it will also cause water contaminations due to improper disposal. So, it is not in line with the SDG 6, clean water and sanitation. At the same time, the incineration process is fueled by several organic waste that are renewable energy sources. In favor of SDG 7, affordable and clean energy, which aims to reduce dependence on non-renewable energy sources. Socially, the operation of the incineration plant provides jobs for the local population, in line with SDG 8, decent world and economic growth. At the same time, it also has negative impacts on society, such as generating noise pollution and placing a burden on local traffic, which is not in line with SDG 11, sustainable cities and communities. On the economic side, incinerating waste to generate electricity saves energy costs and favor the local economy. Finally, we conduct some surveys on the public perception of incineration, which is seen by organizations such as Zero Waste Europe as destroying the value of the waste and as a better way to recycle than incinerate. However, proponents of incineration believe that the purpose of incineration is to dispose of waste products that are not suitable for recycling, and therefore it does not contradict recycling. It has been shown that the countries with the highest waste incineration rates, Denmark, Norway, and Sweden, for example, all incinerate at least 50% of their waste, also tend to have higher rates of recycling and composting of organic materials and food waste. Therefore, to increase public acceptance of incineration technology, governments should improve information transparency and communication with the public as a way to better implement incineration technology.
In conclusion, urban garbage is a long-term source of pollution, and untreated or improperly treated can cause serious pollution problems. Incineration technology is a way to achieve the transformation of waste into energy, addressing issues such as the continuous deterioration of urban environments caused by the high growth rate of urban solid waste and the increasing phenomenon of garbage surrounding cities. In order to improve the environment and the society, innovative technology for different stages of incineration should be developed. The policy transparency should be strengthened to increase people's acceptance. Incineration technology still has two sides, and more comprehensive policies need to be formulated to further develop it, in order to adapt to more diverse needs and reduce adverse effects to a certain extent. Thank you for watching this video.